Hi students, welcome back to class. In the previous class, we looked at covalent bond. If we say covalent bond involves sharing of electrons. Covalent bond involves sharing of electrons. Now, we said covalent bond has two types. That's ordinary or pure covalent bond and dative or coordinate covalent bonding. And we said for ordinary covalent bond, it involves two atoms donating electrons for sharing. And of course, we said pure or ordinary as pure or ordinary as homonuclear and heteronuclear. Homonuclear and heteronuclear. Homonuclear deals with atoms of the same element, while heteronuclear deals with atoms of different elements. Then we talked about coordinate covalent bond that in where one atom drop electron for sharing, while the other do not drop electron for sharing. And then this is, we said this is evident in complexes and etc. It's evident in complexes etc. Now in today's class, we are going to be going to metallic bond. First, metallic bond. We are going to be going to metallic bond. We are going to be going to metallic bond. Metallic bond is a bond that exists in the atoms of metals. Take for instance, when you have the crystalline structure of sodium. In the crystalline structure of sodium, you have it here, and of course this is studied by X-ray. We use X-ray to study crystalline structure of metals. Metallic bonding is chiefly responsible for the high boiling and melting point of metals, and of course some other physical properties like the tensile strength and the shape etc. So that's metallic bond. Another one that we have is van der Waals forces. The van der Waals forces. The van der Waals force is the weakest forces of attraction in molecules of compound. It is chiefly responsible for liquefaction of compounds. An example of van der Waals force or compounds have van der Waals force is CO2, and that's why it is easy to liquefy CO2. Van der Waals force is subdivided into two, and that is London dispersion force. London dispersion force and dipole moment. London dispersion force and dipole moment. London dispersion force occur or happen with non-polar molecules. Non-polar molecules or compound. Non-polar molecules or compounds. Example are CO2, H2, N2, Cl2, O2, etc. In these compounds or molecules, an instantaneous charge is generated, which causes the bond to be formed. But the bond is not strong enough, and of course breaks away. And that's why it is easy to liquefy most of these molecules or compounds that you have here. That's London dispersion force between two non-polar atoms. Now, for dipole moment, it exists with polar molecules or atoms. Polar molecules or atom. An example is ACl. In ACl, where you have H plus and Cl minus, you have an instantaneous charge plus, and this one negative. It's being formed here. So non-polar and polar molecules. So instantaneous charge is also created, but because it is not strong enough, the bond is broken off. So van der Waals forces is the weakest force of attraction between molecules, and it's chiefly responsible for the liquefaction of substances. And then we said it is subdivided into two: London dispersion force and dipole moment. The last but not the least of the bond that we are going to talk about is hydrogen bond. Hydrogen bond. We said hydrogen bond exists between hydrogen and highly electronegative elements. Hydrogen bond exists between hydrogen and highly electronegative elements. Most of the time, electronegative element from group 5, group 6, and group 7. So in the group periodic table, let's say you have group 5, 6, and 7. You have nitrogen, phosphorus, you have oxygen, sulfur, and then you have fluorine and chlorine. Hydrogen bond increases, the strength of hydrogen bond increases across the period but decreases down the group. So down the group now, where you have HF and ACl, HF and ACl, the bond, the strength of hydrogen bond here is like this. That means the strength of hydrogen bond in HF is greater than that of what? ACl. Why? Because we said hydrogen bond, the strength of hydrogen bond increases across the period but decreases down the group. Now in this one too, the strength of hydrogen bond in H2O is greater than that of H2S. Don't forget, the hydrogen bond is bond that exists between hydrogen and high electronegative elements. So, and of course, the strength of hydrogen bond in NH3 is greater than that of what? pH3. pH3. Now, having said that, we also have to say that to put them together, the strength of hydrogen bond is like HF greater than ACl, ACl is greater than H2O, H2O greater than H2S, H2S greater than NH3, NH3 greater than pH3. That this is decreasing strength of hydrogen bond. So among the 6 compounds here, it is phosphine pH3 that have the least hydrogen bond, while HF has the greatest hydrogen bonds in terms of strength of the hydrogen bond there. So again, you should also note that hydrogen bond is responsible for high boiling point of some compounds like water and ethanol, C2H5OH. Hydrogen bond is responsible for high boiling point of water, which is 100 degrees Celsius, and C2H5OH, ethanol, which is 78 degrees Celsius. Of course, in terms of molecular weight, they have low molecular weight, but because of the presence of hydrogen bonding, they have high boiling point. So when they ask you why is water and ethanol having hydrogen high boiling point, due to the presence of what? Hydrogen bonding. So hydrogen bond is responsible for high boiling point of some compounds. In a nutshell, we've talked about metallic bond that exists between metals, and responsible for some physical properties like tensile strength, high boiling and melting point. We've talked about van der Waals forces, the weakest forces of attraction that is responsible for liquefaction of some substances, and it's subdivided into London dispersion force and dipole moment. And we've talked about hydrogen bond, the bond that exists between hydrogen and highly electronegative element, which is responsible for high boiling point of water and ethanol. So, in a nutshell, we have talked about 5 type of bond. We talked about ionic or electrovalent bond. We have talked about covalent bond. We have talked about metallic bond. We have talked about van der Waals forces, and we have talked about hydrogen bond. This comes to the end of chemical combination, and of course, I hope you have learned 1 or 2 things as far as chemical combination is concerned. Continue to learn chemistry, continue to improve. Cheers to your good. Thank you.